Solving an equation involving radicals. So here's the steps. Step 1. Isolate the radical on one side of the equation. Step 2. Raise each side of the equation to a power that is the same as the index of the radical so that the radical is eliminated. So the main goal here is to get rid of the radical sign. So if you have a square root, you take power of 2. If you have a cube root, that's the index 1/3 or 3. So you actually raise to the power of 3. And step 3, solve the resulting equation. So you're just finding the x. And the last step, step 4, you always check your answer. So check each proposed solution in the original equation. So there will be a time that the answer is not the true solution. So when you plug in to the original equation, so make it sure it's a true statement. So here's the simple example for a radical equation. Square root of x is equal to 1. So obviously x here is 1. So when you take square root of 1, that would be 1. So the procedure shows that you have to get rid of the radical symbol by taking the square. So we take the square on the left side to eliminate the radical sign and do the same thing on the right side. So x therefore is 1. Now don't forget to always check by plugging that in back. So you have 1 for x equal to 1. So that's 1 equals to 1. So therefore that's true. So 1 is the true solution for this example. So put that in a solution set. Okay, next example. Now we have to put the radical. So here's the radical expression and put this in one side of the equation. Right now there are two terms on the left side. So what we're doing now is moving this to the right side. And it becomes positive. I'm trying to eliminate the radical here by taking the square on this side and do the same thing on the other side. So I will get x squared here equals to 15 minus 2x. So the radical symbol actually got eliminated. And then put this in one side of the equation to form a quadratic equation. So I move negative 2x to the left, becomes positive 2x. I will move 15 to the left, becomes minus 15. And then the right side now is equal to 0. And then I can apply factoring to find my x, or you can use quadratic formula. So your a here would be 1, b is 2, c is negative 15, and then solve for your x using the formula. So using the factors of x squared here, I put x here, factors of negative 15, that would be negative 15 times 1, 15 times negative 1, negative 5 times 3, and 5 times negative 3. So which of these factors, when you add, it will give you positive 2. So that would be the last one. So I'll put plus 5 here and then minus 3 on the other side. You can always check by uh, multiplying the inner terms and the outer terms. It gives you the middle term, which is 2x. Okay, and then apply the zero factor property by setting x plus 5, the first factor, equal to 0, and do the same thing on the other factor, which is x minus 3. So x here is equal to negative 5. So that's the first value for x. X on the other factor would be x is equal to 3. That would be the second answer. So now we have to always check our answer in order for us to know which one goes to the solution set. Okay, so are these two answers are valid or not? So let's start with negative 5. So when x is equal to negative 5, you plug that in to the original equation, you'll get negative 5 minus 15 minus 2 times negative 5, 0. So calculating, so negative 2, so right here negative 2 times negative 5 becomes a positive 10. Add that to 15 is 25, square root of 25 would be a 5. And then adding that to negative 5, it gives you negative 10. So this is false. So negative 10 equals to 0. It's false. So negative 5 is not the true solution. So disregard negative 5 in the solution set. So we're going to try x is equal to 3. So 3 here minus, so this is the original equation, minus 2 times 3 equals 0. So 3 minus 15 minus 6. So that should be a 9. Square root of 9 is a 3. So that would be 3 minus 3 is equal to 0, which is true. So in the solution set, we can only actually put 3 as part of our answer. So here, you can see 3, it's the only answer. Again, 3 is the only answer in a solution set for x for this problem. Next example. Now, in this example, you're given with two radicals in this radical equation. So what we can do, we have to put one radical on one side of the equation. In the given equation, you have two radicals on the left, so I have to move one to the right. So I'll go equals to 1. I have to move my negative square root of x plus 1 to the right side. becomes 1 plus square root of x plus 1. And then I have to apply now the square on both sides to eliminate the radical. So this one cancels out for the radical sign. You'll get 2x plus 3 on the left. And then on the right side, it's a power of 2. You square that, so there's a square binomial. I'll get 1 plus 2 radical x plus 1, then plus x plus 1. So what you're trying to do here is applying the square binomials. So what I did, I squared the first term. 1 times 1 is a 1. And then I multiply the first and the second term. 1 times radical x plus 1 times 2. I'll get 2 square root of x plus 1. And then the last term, or the second term, I square that, and it gives me x plus 1. So well, think about if you're going to have the longer way, you're going to multiply this in this manner. So using fuel, you go and multiply this like this. So that would be the long way to solve the expression. And it will give you the same result anyway. Okay, so we will combine like terms. I have to move the terms from the right to the left. Try to isolate a radical symbol, so that should be 2x. I'll use the same color, 2x um, minus x. I move the x from the right to the left, becomes a minus, plus 3, and I have a 1 there. I have to put minus 1 here from the right, and another 1 minus 1 from the right also is equal to 2 radical x plus 1. And then what is 2x minus x is x, and 3 minus 1 is a 2, minus 1 is a 1. And then I still have a radical symbol here, so I apply power of 2. On the right side, I'll do the same thing on the left side. So I will get here 4 times x plus 1. On the left side, I will apply the square binomial again. So I'll take the square of the first term, x squared, and then I'll go x times 1 is x times 2, which is the power. It gives you the middle term, which is 2x. And then the second term 1, you just take 1 times 1. Then square that, it gives you a 1. And then simplifying, on the right side, I'll get 4x plus 4 by multiplying. 4 times x is 4x. 4 times 1 is 4. And then copy all the terms on the left side. And then we'll combining like terms. Try to form the quadratic equation by isolating everything to the left, and then the right side should be a 0. So 4x becomes a minus 4x. And then plus 1 minus 4 is equal to 0. Okay, so let's have to combine like terms. So 2x minus 4x, it gives me negative 2x here, or minus 2x. 1 minus 4, it's minus 3 or negative 3. equals 0. And then I will apply factoring. Again, you can always use quadratic formula. So your A here would be a 1, B is -2, C is -3, and calculate. So my factors for x squared is x and x. And then I have a -3, it's a prime number. So I'll put -3 here since we have a negative middle term, and then plus 1 on the other side. So you can check by multiplying the inner terms and the outer terms, it gives you -2x. And then you set each of the factor equal to 0. X minus 3 is equal to 0. And the other one, x plus 1 is equal to 0. So x therefore is 3. By moving -3 to the right side becomes a +3. And then x equals on the second factor. I I will move 1 to the right side becomes a -1. And that will be the value for x there. Okay, and then we check our answers if those two x values would be the true solution for this problem by plugging this in back to the original equation. So 2 times 3 plus 1 minus 3 plus 1 is equal to 1. So that would be, um, it's not plus 1, it's a plus 3 from the original problem. So that should be now 2 times 3 is 6, plus 3 is 9, square root of 9, that would be 3, minus 3 plus 1, it's a 4, square root of 4 is a 2. So this one is true statement. So I will mark this out. 3 is a true solution for this problem. Okay, so let's have other value for x, which is 1. So I have 2 times, I mean -1 for x. So that should be -1 for x here. And then plus 3 minus -1 plus 1 is equal to 1. So 2 times -1 is -2 plus 3, that should be a 1, square root of 1, it should be a 1. And then we have -1 plus 1 is a 0. Square root of 0 would be 0 is equal to 1. So this is true also. So the two values are correct. And you can put that in the solution set. These are true solutions for uh, your x values. So -1 first, comma, 3. Again, for this problem, you have two answers. That's -1, and the other one is +3. Okay, last example. Now, in this last example, one radical on the left and the other one is on the right, so we don't move any radicals. So unlike the previous example, you have two radicals to the left, so I have to move one to the right. So according to the rule. So this one, you have only one to the left and only to the right, so you are on the right place, and you can start squaring now. So we can actually take the square on both sides of the equation. But remember, when you take the square on the right side, it should be the two terms inside the power of 2. So the radicals here cancels out. What's left would be x minus 2 on the left side. And then on the right side, again, this is a square binomial. So I can take 3 times 3, that should be a 9, minus, so we're taking 3 times a negative square root of x plus 1, that should be a negative 3 square root of x plus 1 times 2, which is the power. It gives you a negative 6 here, square root of x plus 1. And then you take the square of the second term of the binomial. So it gives you plus x plus 1. Again, the same as we did last time. If you want to take the longer way, you can actually do 3 minus square root of x plus 1 times 3 minus square root of x plus 1. And then do the FOIL method. You go like this, and then it gives you the same results. Okay, so we're trying to combine like terms here by moving some terms from the right to the left, except for the radical. So we'll just put the radical expression on the right side. So I'll move x from the right to the left, becomes a minus x. And then I have a 9 also from right to left, it's a minus 9 now. And then I have a 1 from the right, it's a minus 1 equals negative 6 square root of x plus 1. So again, what we're trying to do here is moving all the terms from the right to the left except for the radical expression, which is negative 6 square root of x plus 1. Okay, and then we combine like terms so that x minus x is equal to 0. And then negative 2 minus 9, that's negative 11, minus 1 is a negative 12. So we have a negative 12 here equals negative 6 square root of x plus 1. We have to eliminate the radical symbol by taking the square on the right side and do the same thing on the other side. So it gives us 36 times x plus 1. On the other side, that should be 12 times 12, that should be 144. So that's a power of 2. So that's 144. And then we're going to solve for x by dividing 36 here. And then 36 also here. So the 36 will be cancelled out. So we will have x plus 1 and 144 divided by 36. It gives us 4. And then solving for x, you have 4 minus 1. I move 1 from the right to the left, so it becomes negative. And then now you have 4 minus 1. That would be a 3 for your x. So you can rewrite that as x is equal to 3. It's just the same thing. I'll just put or there. So x is equal to 3 or 3 is equal to x. So now we have to check if that is the right value. So checking by plugging that in back to the original expression. So 3 minus 2. equals 3 minus, we plug in the value for x, which is 3 plus 1. So 3 minus 2 is a 1. Square root of 1 is a 1. Equals 3 minus, that's 3 plus 1. That should be 4. And square root of 4 is 2. So this one is true. So we have only one value for x here, which is 3, which is the true value. Okay. So as a summary, sometimes your answer would be 2, sometimes it's 1, sometimes it's none. So make it sure that you have to plug in back your result, your x value, back to the original equation to check whether that value is a true or valid answer by testing it. And your statement should be true if that is part of the value. Otherwise, it's false. So you're going back to the empty set if there's no valid answers.